All right, ladies and gentlemen, welcome to our next lesson about vectors and matrices. Once again, don't worry. Step one of dealing with matrices is don't panic. Please don't panic. Please don't panic. You will need a graphing calculator, or at least a calculator that can get the determinant of a matrix. Because what's going on today is you are going to get the area of a shape that's on the coordinate plane using vectors and or matrices. And there are two different methods you can use to get the area of these shapes. So these are both number one on your assignment right here. And there's two different ways to get your area. Method one is to take the coordinates of the three vertices and put them in a matrix, stack them up, and then add a column of ones. Once you have this lovely matrix, you're going to get the determinant of this matrix. And once you have the determinant of that would be the area of the parallelogram that makes that triangle. And since that's not the triangle, you're going to cut it in half. Just like area of a triangle is 1/2 the area of a rectangle, you're going to get the determinant of this, and then cut it in half, and that'll give you your area. So take a moment to put this matrix in your calculator, and then get the determinant of it and cut that in half. Go ahead and put that in and come back and check. Alright, did you get it in? Did you get your determinant? You should have gotten 52 for your determinant. And that's the determinant part. You do have to cut it in half because it's a triangle instead of the full parallelogram. And so you should be getting 26. So that's method A. People tend to like that one because it requires, less thinking, less work in a sense. But there's another method for getting the area of that triangle or parallelogram. And that's to get the vector that goes from a common point. So you go from E to D, it'll make the vector -20 and -6. If you get the vector from E to F, then it'll make the vector -22, -4. You then get the determinant of that matrix using those two vectors and cut that in half. So take a moment to put this matrix in and get the determinant of it, and we'll see if we got the same answer. Go ahead, put it in, check it. Alright, did you get your determinant? Did you get -52? And did you cut it in half? Good. Well, something to be aware of, area is not negative. That's just not going to happen, at least in our realistic world that we live in. I'm not dealing with like theoretical physics and fun stuff like that. You can deal with that later, but we're just going to assume that area is going to be positive. And so really I should put like a big old absolute value around these little formulas. Yeah, you're going to turn your area into positive. So we're looking at 26 again. And so there's two methods to get your same answer, kind of based on which you're going to go with. We have been doing a lot of vector stuff, and so if you like doing the vector thing, you can. But if you don't mind making a large matrix, putting your matrix in your calculator and get determinant, then this one is probably what you're going to go with. People tend to like the big matrix method more than the small matrix method. So let's go through a few examples, just so you can kind of see in action and be able to check your work. Jump down to number 9. If you're going to get the area of the triangle, you got to get your vertices, which I have conveniently already figured out what those coordinates are, and I put them in a matrix already. So you got -8, -8, -9, 7, 2, and then 8, -7. Go ahead and put those in the calculator and get the determinant, which is looking like 1/2 of, put it in, get the determinant. Alright, let's have you check and see how you did. You should have gotten -146. Remember, we can't have a negative area, and so we're looking at 1/2 of +146, which comes out to be 73. So it's 70, whatever the units are squared, because, areas square units. Let's do another example. Let's go to the back, and on the back you need to get the area of the parallelogram that's made with those 4 vertices, and this time when you get the area of the parallelogram, you actually only need 3 of the vertices. On this example here, we're going to use the vector method just so you can see it. But let's get the vector going from B to A. Well, to go from 5, 0 to 0, 0 is you have to go left 5, and then 0 doesn't change at all. And then we go from 5, 0 to 3, 4. Well, you have to go down 2 in the x's and up 4 in the y. And we have these two vectors. And so now we have those vectors. We can turn it into a matrix. You just put those numbers in their own row. And we're going to get the determinant of this matrix. So take a moment to put that in your calculator and get your determinant. Or you can get your determinant by hand if you remember how to do that. All right, for your determinant, you should have gotten negative 20. Once again, we're not going to have negative area, so we're going to turn that to be positive. And since it's a parallelogram, you don't have to cut it in half, just the triangle ones that you have to cut in half. So you're looking at 20 units squared. So 20 like boxes on the coordinate plane there. Let's jump to another one. On 23, you have this lovely parallelogram here. And you need to get the area of this parallelogram. I have already figured out two of the vectors here for you. And if you put those vectors in, you get a determinant, you can get that figured out. So take a moment, put that in your calculator, and get the determinant to figure out the area. All right, so let's see. Did you get negative 68? Hopefully you got negative 68. Once again, we're going to make it positive, and we want our units to be squared. This is not the only method you can go with. You may have noticed I didn't do the big matrix method. I want to show you what that looks like so you can see it. Let's do some erasing here. To do that, you just need to find 3 vertices. You don't need the 4th one. So go ahead and get your coordinates here, looking at negative 7, negative 3, and then negative 1, 1. And then this one down here is at 4, negative 7. And you can put those into a big matrix. So we got negative 7, negative 3, negative 1, 1, and then 4, negative 7. And then add a column of 1s there, and you can get the determinant of that. So go ahead and put that in your calculator. Let's check and make sure you're still getting 68. All right, did you still get 68? Well, negative 68, I did. So you can use either method. This is, once again, usually a preferred method because you don't have to get the vectors. But if you like getting the vectors and you like using a smaller matrix, you can go with that. But there's your options. To get the area, put the vertices in a matrix and get a determinant, and you're good to go.